Welcome back, everybody. Welcome to Chapter 7, probably one of the best and most loved chapters in our entire book for the whole year, just because it's really cool, it's really different, and it's actually kind of fun, and the operations and math that was involved is very, very user-friendly. So Chapter 7 is all about what we call a matrix, and the plural of matrix is just matrices, but it comes from the word matrix. No, not the Keanu Reeves film from the 90s and early 2000s. That was a great trilogy. You should watch that. But this is a different kind of matrix. And then we'll learn about what determinants are a little bit later. But for today, we're just going to practice what is a matrix and what kind of things can we do with the matrix. So section 7.1 and 7.2 go really, really well together. And we'll start with that. 7.1, your notes, you can write matrices and system of equations. But we're going to really deal with just basically matrices by themselves. So if you just want to write Introduction to Matrices, that's a fine, fine chapter title here. All right, well, let's define what a matrix is. A matrix, guys, just looks like this. It's a rectangular array or rectangular arrangement of numbers, and we put them into rows and columns. That's all a matrix is. It's just a way of rearranging numbers and representing them in a different way. This will be really useful later when we solve equations and we don't have to plug x's and y's and stuff. We just plug in the numbers and everything takes care of themselves. So matrices are awesome. So first of all, look and see how we divide them up. We have matrices that are put into rows and they're put into columns. Okay, so rows go left and right and columns go up and down. So I can tell you right now, if you just look at matrix A, and also why don't you see that, you know that we labeled this matrix with a capital letter. Generally, we do label matrices with capital letters. Matrix A, matrix B, matrix C, and so on. Well, looking at this matrix A that I have, it's got 6 numbers in it, 3, 2, -1, -2, 0, and 9. Those are called the entries. The entries are the numbers inside. So it's got 3, 2, -1. It's got -2, and 0, and 9. Those are all the numbers inside the matrix, so sometimes we'll refer to those as entries. And also, if you look and see how it's arranged, it has 3 columns, 1, 2, 3 columns, and it has 1, 2 rows. So we can talk about the size of it, or another word is the dimensions. And the book sometimes uses the word order, but we don't use the word order too much. We either say the size or the dimensions. But the order is a good word too. The dimensions is always rows by columns. It's always in that order. So you can think of it in terms of reverse alphabetical. It's R and then C. Rows and then columns. Oh, let me fix my word columns here. So as you see here, does it make sense, guys? When you look at it, oh gosh, I can't even spell the word columns. There you go. If you look at it, I've got 2 rows and 3 columns. That's 2 rows, 3 columns. So therefore, we call this a 2 by 3 matrix. So the size or dimensions of this matrix is a 2 by 3. 2 rows and 3 columns. Just a little bit of English here. If we take the word matrix and we have 1 matrix and we make a plural, we have 2 matrices, 3 matrices, 4 matrices. So that's what matrices means. It just means the plural of matrix. All right, now, what can we do with these? Well, let me describe a couple more for you guys. We have a couple of special types. We have something that's called a row matrix. And a row matrix is literally just made up of one single row. So does it make sense that this one over here is a row matrix? Because it has just one single row. Can you figure out how many columns it has? If you said 4, you're right. So therefore, the matrix dimensions here would be a rows by columns, right? It'd be a 1 by 4 matrix because it has 1 row and 4 columns. All right. How about a column matrix? Well, if you know what a row matrix is, a column matrix makes sense. It's just a single column. So this has one single column here. And how many rows? You got it. So if this is R by C, this is a 3 row by 1 column matrix. That's a 3 by 1 matrix. How about a square matrix? Square matrix is kind of cool because it actually looks like a square, meaning the rows and columns are the same number. If you look over here, if I count 1, 2, 3 rows and 1, 2, 3 columns, this would be a 3 by 3 matrix. So a square matrix, you can tell, always has the same number of rows, so that number should match the same number of columns, that number. And finally, kind of boring, but we have something called a zero matrix. It can be really any size. It's just the fact that every single entry inside is a zero. But hey, do you want to double check? What would you call this in terms of its dimensions or its size? Rows by columns? This is 2 rows by 2 columns. So that's a 2 by 2 matrix. So those are the 4 special types that we'll see. You want to try those 4 for me? Why don't you pause the video, write down what the order or dimensions are, and come back and check your answers with me. Okay, we check these. The first one on the top left has 1 row and 1, 2, 3, 4 columns. This first one is a 1 by 4 matrix. 1 row and 4 columns. How about the one next to it to the right? This one has 1, 2 rows, 1, 2 columns. That one's pretty easy. That's a 2 by 2 matrix. How about the bottom left? Let's count. 1, 2, 3 rows and only 1, 2 columns. Okay, if we go row by columns, it's going to be a 3 by 2 matrix. 3 rows and 2 columns. The last one's kind of tricky. Let's count the rows and columns. Ready? All right, it's got 1 row and it's got 1 column. It's a single entry. So this would be, how strange, it's a 1 by 1. Is that also a square matrix? Yeah, okay. We can call that a square matrix. The entries for the rows and the columns are the same number. So yeah, we can call them a square matrix. All right, now, what kind of math can we do here? Ready? Let's play. Now, the rest of 7.1 gets really hardcore in terms of system equations, which we might get to a little bit later. We might come back to it, but I just want to play with the most basic operations that we can do. So section 7.1 is kind of done for now. Let's just jump ahead and try section 7.2. So take a quick breather. And we're back. All right, 7.2. Now, what can we do with matrices? All different kinds of things. We can add, we can subtract, we can multiply. We can't really divide, so we'll find another way to do that later. But for now, we got to figure out the rules. All right. First of all, how do you know if 2 matrices are equal? Well, 2 rules here. Rule number 1. In order to be equal, they have to have the same size or the same dimensions. So a 2 by 2 is not the same as a 3 by 3, so they cannot be equal. Have to be the same size or dimensions. Rule number 2. Well, not only do they have to be the same size, but all the corresponding entries have to be literally the same number. All right, that one's a little bit hard to explain, so why don't we look at this example below. First of all, why don't we find out, rule number 1, do they have the same dimensions? If you look at the left one is a 2 row and a 2 columns, that's a 2 by 2. The one on the right is 2 rows and also 2 columns. So rule number 1 is good. They have the same size or dimensions. Now, when I say corresponding entries, I mean the top left of this guy, is he the same as the top left of that guy? And they are. So far, so good. Let's check each one. Well, okay, these are different, but are they really? Do you agree that -1/2 is the same thing as -0.5? So they really are the same. Okay, let's keep going. How about 1/4 and 0.25? I think they're the same. And finally, 0 is always equal to 0. So are they equal? Yes, they are. Those are equal matrices. So if I wanted to, I can go a little further and say, well, if this is matrix A, and this is matrix B, I can say that A is equal to B. Matrix A is equal to matrix B. So first rule, they have to have the same size or dimensions. Second rule, the corresponding entries have to be the same between both matrices. All right, now let's learn how we can add and subtract. This is cool stuff. All right. Biggest rule right here, a big star, guys, is you cannot add or subtract unless they have the exact same dimensions. So a 2 by 2 and a 3 by 3 cannot add or subtract. They have to be the same dimensions. Must. But the good news is, once they are, all you have to do is just literally add or subtract the corresponding entries. So let me give you example number 1. But we have to check the dimensions. All right, they look a little strange on number 1, but can you figure out rows by columns for each one? All right, the one on the left has 3 rows and 1 column. And the one on the right is 3 rows and 1 column. Okay, so they're the same size or dimensions, so we can add or subtract them. Well, all you have to do is just add or subtract the corresponding entries. So 3 plus 1 and -4 plus 0 and 7 plus 3. That's all you have to do. Just take the corresponding entries and add them together. Final answer for number 1. Now, if you're adding them, they're 3 by 1s, your answer should also be a 3 by 1. So 3 plus 1, -4 plus 0, and 7 plus 3. And that's my final answer for number 1. Why don't you pause the video and try number 2 and 3 on your own and check them with me, guys. I'll see you soon. All right, number 2. Why don't we take number 2? Let's do the check. Do they have the same dimensions? So right now I can see that the left one is a 2 by 2, 2 rows, 2 columns. And the one on the right is also a 2 by 2. So we're good to go. We can add or subtract them. Let's just take the corresponding entries. So that means my answer is also going to be a 2 by 2. So let's take the 8 and the 2. And I get 8 minus 2 is, that goes up on the top left because the 8 and the 2 are up on the top left. How about the 3 and the -7? Watch your negatives here. 3 minus a minus becomes addition. Bottom left, how about 4 and the 6 subtracting? We get -2. And then finally, why don't we take the 0 and the -1. Again, watch your double negatives. 0 minus a minus becomes plus. And there's my final answer for number 2. Pretty easy, right? I love matrices. All right, number 3, our last one for this page. Let's check and see. Can we add and subtract these? Should we do dimensions first? All right, the one on the left is a 2 by 2, and the one on the right is a 2 by 1. Ooh, wait a minute, they're not the same dimensions. That means, can we do it? No. So we can say it's not possible or no solution because they're not the same size or dimensions. Yay, that's good. That means I don't have to do anything more with it. I'm done. They have to be the same dimensions if we want to add or subtract them.